The universe is a vast, whispering gallery of mysteries, each corner hiding secrets that defy our understanding and challenge what we think we know. Look up at the night sky, and you're not just seeing stars, you're gazing into a cosmic puzzle where every flicker of light could be a clue to something extraordinary. And among the most enigmatic pieces of that puzzle are the strange, almost otherworldly objects catalogued in the new General Catalogue, the NGC. This isn't just a list, it's a treasure map to the weirdest, most baffling celestial phenomena astronomers have ever encountered. From ghostly nebulae that glow like spectral fingerprints to galaxies twisted into shapes that shouldn't exist, the NGC is a testament to the universe's endless creativity. Today, we're diving deep into 30 of its most astonishing entries, objects so peculiar, they seem ripped from the pages of science fiction. Picture a star so massive it's literally tearing itself apart, or a nebula that looks like a giant, glowing eye staring back at us from the void. These aren't just curiosities, they're cosmic riddles that have kept scientists awake for decades, whispering questions about how the universe really works. What could create a galaxy shaped like a ring, floating in space like a celestial wedding band, or a cloud of gas so turbulent it mimics the aftermath of a stellar explosion, except nothing actually exploded? The answers, when we find them, rewrite the rules of astrophysics. This journey isn't just for astronomers or space enthusiasts, it's for anyone who's ever looked up and wondered what's really out there. Because these objects aren't just distant oddities, they're mirrors reflecting the sheer, staggering diversity of the cosmos. Some are beautiful, some haunting, and some so violently energetic they defy logic. And as we explore them together, you'll start to see the night sky not as a static painting, but as a living, breathing entity, full of drama, chaos, and wonders we're only beginning to comprehend. So buckle up, by the time we're done, you'll never look at space the same way again. The first stop on our tour of cosmic oddities is a galaxy so striking, it looks like it's staring back at you with a shiner. The Black Eye Galaxy, also known as Messier 64. Nestled in the constellation Coma Berenices, this spiral galaxy earned its nickname from the thick, dark band of dust swirling around its bright core, giving it the appearance of a celestial black eye. But that haunting feature is just the beginning of its mysteries. What makes this galaxy truly bizarre isn't just how it looks, it's how it moves. Astronomers discovered something downright unsettling about the Black Eye Galaxy's inner workings. Its outer regions of gas and stars are rotating in the opposite direction from the inner disk. Imagine a record spinning clockwise while the outer edge suddenly decides to go counterclockwise. It's that level of cosmic defiance. This eerie counter-rotation isn't just a quirk, it's a ghostly fingerprint of a violent past. Scientists believe this galaxy was born from a cataclysmic collision, a head-on crash with another galaxy billions of years ago. The gravitational chaos of that merger sent shockwaves through the gas and dust, leaving some of it spinning backward like a cosmic whirlpool caught in reverse. But the strangeness doesn't end there. That iconic dark band, it's not just a passive veil of dust, it's a turbulent graveyard of stellar material, where newborn stars are constantly battling against thick clouds of debris. The collision compressed gas clouds so intensely that it sparked bursts of star formation, creating pockets of brilliant blue young stars blazing against the darkness. And yet, despite all this violence, the Black Eye Galaxy wears its scars with an eerie elegance, a reminder that even in the chaos of the cosmos, beauty and destruction are often intertwined. What's truly humbling about this galaxy is how it challenges our assumptions. We often think of galaxies as serene, orderly spirals, but Messier 64 shatters that illusion. It's a cosmic fossil, a snapshot of the universe's brutal ballet of collisions and rebirths. And as we unravel its secrets, we're forced to ask, If something this strange exists in our cosmic backyard, what other wonders or terrors are lurking in the depths of space? From the eerie gaze of the Black Eye Galaxy, we turn to a cosmic structure so iconic, it could wear its fame, the Sombrero Galaxy, officially known as Messier 104. Floating in the constellation Virgo, this stunning spiral galaxy looks like it was plucked straight from a mariachi band's wardrobe, with a brim of dark dust encircling a glowing central bulge. That thick, tilted dust lane isn't just for show. It's a cosmic obstacle course, blocking starlight and weaving shadows across the galaxy's face like intricate lace. But what makes the Sombrero more than just a pretty silhouette is the sheer scale of the drama unfolding within it. At its heart lies a supermassive black hole, one of the most massive ever detected, a beast weighing in at around 1 billion times the mass of our Sun. To put that into perspective, our own Milky Way's central black hole is a lightweight in comparison, a mere 4 million solar masses. This Leviathan doesn't just lurk quietly, it shapes the entire galaxy around it, heating gas to millions of degrees and sending ripples of energy through the surrounding dust. Yet, for all its power, the Sombrero's black hole is oddly well behaved, unlike the violent, jet-spewing monsters found in other galaxies. This one seems content to sip matter slowly, like a gourmet savoring a fine meal. But the real head-scratcher, the galaxy's enormous halo, a vast, diffuse cloud of stars stretching far beyond its visible disk. Most galaxies have halos, but the Sombrero's is bizarrely overstuffed, packed with ancient stars that shouldn't be there in such numbers. One theory suggests this galaxy is the product of a long-ago merger, a cosmic tango where another galaxy was torn apart and its stars scattered into this sprawling fringe. Another possibility, the Sombrero might be a rare lenticular galaxy, a hybrid between a spiral and an elliptical, caught in a transitional phase that explains its odd structure. What's undeniable is that this galaxy is a masterclass in cosmic contradictions. Its serene beauty masks a turbulent history, its elegant dust lanes hide a ravenous black hole, and its seemingly simple shape belies a halo teeming with stellar ghosts. The Sombrero doesn't just invite admiration, it dares us to ask how such contradictions can coexist. And as we study it, we're reminded that even the most familiar-looking objects in space can harbor secrets that rewrite the rules. After all, if a galaxy this polished can hide such chaos, what else are we missing in the depths of the dark? Now, let's drift toward one of the most photogenic galaxies in the cosmos, the Whirlpool Galaxy, officially known as Messier 51. Located a breathtaking 23 million light-years away in the constellation Canes Venatici, this grand design spiral is so flawless, so hypnotically symmetrical, it almost looks like a celestial pinwheel caught mid-spin. Its arms, thick with ribbons of blue star clusters and pinkish star-forming regions, spiral outward with such precision they could have been drawn by the hand of some cosmic artist. But this beauty isn't just sitting pretty, it's locked in a gravitational waltz with a smaller companion galaxy, NGC 5195, and their dance is rewriting the galaxy's fate in real time. What makes the Whirlpool so fascinating isn't just its good looks, it's the violence hidden beneath them. That smaller companion isn't just a backdrop, it's a disruptor, tugging mercilessly at M51's arms like a child pulling taffy. The gravitational strain between them has warped the Whirlpool's spiral structure, stretching its arms into exaggerated arcs and triggering explosive waves of starbirth. Everywhere these tidal forces compress gas clouds, new stars ignite hot, blue, and brilliant, painting the galaxy's arms with stellar fireworks. In some regions, star formation is so intense it outshines entire galaxies, a testament to the creative chaos of cosmic collisions. Yet the most astonishing detail might be the invisible thread connecting these two galaxies, a bridge of hydrogen gas, stripped away by their gravitational tug of war. This river of raw material is feeding the Whirlpool's star-forming frenzy, a direct pipeline of fuel from one galaxy to another. It's a rare, live-action snapshot of galactic cannibalism, a process that shaped the universe since its earliest days. And here's the kicker: this dance isn't a one-time event. Over the next few 100 million years, the companion galaxy will likely be torn apart entirely, its stars swallowed by the whirlpool in a slow-motion feast. But the Whirlpool Galaxy isn't just a spectacle, it's a Rosetta Stone for astronomers. Its clear face on orientation gives us an unobstructed view of spiral structure and star formation, offering clues about how galaxies like our own Milky Way evolve. It's also one of the first galaxies where the spiral pattern was recognized as a real physical structure, not just an optical illusion, a discovery that reshaped our understanding of the cosmos. So when you gaze at images of the whirlpool, you're not just seeing a pretty face, you're witnessing a cosmic laboratory where gravity's relentless pull crafts beauty from chaos, and where the life cycle of galaxies plays out in swirling, luminous detail. The Cartwheel Galaxy is cosmic wreckage frozen in time, a dazzling, ring-shaped anomaly that looks less like a galaxy and more like a stone dropped into a pool of stars. Officially catalogued as ESO 350-G040, this bizarre structure, located around 500 million light-years away in the constellation Sculptor, is the aftermath of one of the universe's most violent head-on collisions. Picture this: roughly 200 million years ago, a smaller galaxy plowed straight through the heart of a larger spiral, sending shockwaves rippling outward like a gravitational tsunami. The result, a celestial bullseye with a blazing core surrounded by a luminous, star-studded ring stretching 150,000 light-years across. What makes the Cartwheel so mesmerizing isn't just its shape, it's the way it defies the usual rules of galactic evolution. Most galaxies rotate with orderly spiral arms or float as blobby ellipticals, but ring galaxies like this one are cosmic unicorns, accounting for fewer than 1 in 1,000 known galaxies. The key to their formation lies in that precise, destructive ballet. A smaller galaxy must punch cleanly through the center of a larger one, like a bullet through an apple. The impact compresses gas and dust in the victim galaxy's outer regions, igniting a frenzy of starbirth that lights up the ring in brilliant blues and pinks. Meanwhile, the core, jolted by the collision, recoils inward, leaving a void where the spiral arms once swirled. But the Cartwheel isn't just a static snapshot, it's a living lab for stellar rebirth. Those radiant blue clusters dotting its ring aren't just pretty ornaments, they're stellar nurseries less than 100 million years old, churning out massive, short-lived stars that blaze fiercely before exploding as supernova. The galaxy's very structure is a clock ticking through the aftermath of the collision. Over time, gravitational forces will blur the ring back into a more conventional shape, making this a fleeting glimpse into a rare phase of galactic life. What really sets the Cartwheel apart, though, is its haunting symmetry. Unlike other ring galaxies, which often appear lopsided or fragmented, this one's near-perfect circular form suggests an almost surgical precision to the collision. Astronomers suspect the intruder galaxy, now long gone, must have hit at just the right angle and speed to create such a clean ripple effect. And here's the twist: the Cartwheel isn't alone. Two smaller companion galaxies hover nearby, one of which may be the original culprit, though it's now retreating into the darkness, its gravitational fingerprints still etched into the wreckage it left behind. Studying the Cartwheel is like piecing together a cosmic crime scene. Every glowing star cluster, every wisp of displaced gas tells a story of violence and renewal. It challenges our assumptions about how galaxies evolve, proving that destruction can be as creative as it is catastrophic. And as we watch its ring slowly fade over millions of years, we're reminded that even the most stunning wonders of the universe are fleeting, a single frame in a never-ending reel of cosmic change. Hoag's object is the galaxy that shouldn't exist, a pristine golden ring floating in the void with a near-empty center, like a cosmic donut suspended in space. Discovered in 1950 by astronomer Arthur Hoag, this celestial oddity, catalogued as PGC 54559, defies every textbook explanation of how galaxies form. Most ring galaxies, like the Cartwheel, are born from violent collisions, their shapes distorted by gravitational chaos, but Hoag's object is different. Its ring is perfectly symmetrical, its core eerily quiet, and there's no trace of a triggering collision, no nearby galaxy fragments, no telltale debris. It's as if the universe decided to skip the drama and craft a flawless ring by sheer will. What makes this galaxy so baffling isn't just its shape, it's the stark contrast between its two distinct worlds. The outer ring blazes with young, blue stars and pink pockets of ionized hydrogen, regions where stars are born in frenzied bursts. Yet the core, a smooth sphere of aging yellow stars, feels frozen in time, with almost no star formation or the supermassive black hole activity typical of galactic centers. It's like finding a bustling city encircling a ghost town with no roads connecting them. How could such a structure form without the usual cosmic violence? One theory suggests a rare resonance event where internal gravitational waves reshape the galaxy over eons, pushing gas outward to form the ring while leaving the core barren. Another wild possibility, an ancient, unseen collision so perfectly executed it left no scars, like a bullet passing through smoke. But here's where it gets stranger. Peering deeper into Hubble images, astronomers spotted another, fainter ring galaxy, another Hoag-like object looming even farther in the background. This accidental discovery hints that these perfect rings might be more common than we thought, hiding in plain sight. Yet, even with modern telescopes, Hoag's object refuses to give up its secrets. Its serene beauty masks a puzzle that challenges our understanding of galactic evolution. Can a galaxy rewrite its own structure without outside help? And if so, what invisible forces are at work? This celestial enigma does more than just confuse scientists. It invites us to rethink the rules. Maybe galaxies aren't just products of chaos and collisions. Maybe some sculpt themselves into elegance, governed by laws we've yet to grasp. Hoag's object isn't just a cosmic oddity. It's a whisper from the universe, reminding us that for every rule we think we know, there's always an exception floating silently in the dark, waiting to be understood. The Antennae Galaxies aren't just colliding, they're tearing each other apart in a slow-motion cataclysm that's rewriting the rules of starbirth. Catalogued as NGC 4038 and NGC 4039, this pair in the constellation Corvus has earned its name from the colossal, arcing streams of stars and gas flung outward by their gravitational tango, twin tidal tails so vast they stretch hundreds of thousands of light years across the cosmos, resembling the delicate filaments of an insect's antennae. But don't let the poetic name fool you. What's happening here isn't delicate at all. It's a firestorm of creation and destruction, a galactic demolition derby where chaos fuels new life. These galaxies began their dance around 600 million years ago when they first brushed against each other's gravitational fields. Now they're in the throes of a full-blown merger, their spiral arms shredded into twisted ribbons of dust and starlight. The collision has triggered one of the most prolific starburst events ever observed, a frenzy of star formation so intense it's birthed over 100,000 massive star clusters, each blazing with the light of millions of suns. Gas clouds compressed by the gravitational turmoil have collapsed into newborn stars at a rate dwarfing anything in our Milky Way. Some of these stellar nurseries are so dense they resemble globular clusters in their infancy, offering a rare glimpse into how such ancient structures might have formed in the early universe. Yet the antennae's brilliance comes at a cost. For every star born, another is doomed. The same forces igniting this stellar fireworks display are also hurling entire star systems into the void. ejected by gravitational slingshots or consumed in the growing maelstrom at the galaxy's merging cores. Eventually, the two nuclei will coalesce into a single, monstrous elliptical galaxy, their once distinct identities erased, but for now, they're a living laboratory, showcasing every stage of galactic evolution in real time. What makes this collision especially revealing is the sheer diversity of its wreckage. The tidal tails aren't just debris trails, they're cosmic time capsules peppered with star clusters of varying ages. By studying them, astronomers can reconstruct the timeline of the merger like forensic scientists piecing together a crime scene, even more intriguing. The antennae's cores are home to some of the universe's brightest infrared sources, superstar clusters so shrouded in dust, they're invisible to optical telescopes but glow fiercely in other wavelengths. These hidden giants may hold clues to how supermassive black holes form, as their dense cores could one day collapse into the gravitational behemoths that anchor galaxies. The antennae galaxies remind us that destruction and creation are two sides of the same cosmic coin. Their violent embrace isn't an ending, it's a metamorphosis, a reminder that even in the deepest chaos, the universe finds ways to build anew. And as we watch, we're witnessing the future of our own Milky Way, which will one day collide with Andromeda in a spectacle just as dazzling. The antennae are more than a celestial oddity, they're a prophecy written in starlight. The Medusa Merger doesn't just wear its chaos on its sleeve, it flings it across the cosmos in tangled streams of stars, gas, and dust, earning its mythological nickname. Officially catalogued as NGC 4194, this galaxy in Ursa Major is a snapshot of celestial violence frozen in time, its serpentine tails writhing like the snakes of Medusa herself. But these aren't just pretty cosmic tendrils, they're gravitational scars, the aftermath of a brutal collision between two galaxies that's still reshaping their shared future. What makes the Medusa Merger so mesmerizing isn't just its wreckage. It's the way it's turning destruction into creation, fueling one of the most intense starbursts in the known universe. At the heart of this chaos lies a supermassive black hole, but it's not the usual voracious monster. Instead, it's oddly quiet, as if stunned by the collision's aftermath. Meanwhile, the surrounding galaxy is anything but calm. The merger has compressed vast clouds of gas, triggering a firestorm of star formation so fierce, it's birthed superstar clusters, dense knots of young, blue stars that outshine entire galaxies. Some of these clusters are so massive, they could one day evolve into globular clusters, the ancient stellar cities that orbit mature galaxies like our Milky Way. The Medusa Merger is essentially building its own future in real time, forging the very structures that will define it long after the collision's dust settles. Yet the most striking feature isn't the starburst or the quiet black hole. It's those serpentine tidal tails, stretching tens of thousands of light years. These streams are more than just debris, they're cosmic rivers of possibility. Within them, pockets of gas are collapsing into new stars, forming isolated communities that might one day become dwarf galaxies of their own. It's a reminder that even in the wake of violence, the universe finds ways to create. And here's the twist, the Medusa Merger isn't unique. It's part of a broader family of galaxies called luminous infrared galaxies, which glow fiercely in infrared light due to all the dust-shrouded star formation. These galaxies are rare in our local universe but were commonplace billions of years ago, suggesting the Medusa is giving us a glimpse into the cosmos's tumultuous youth. What's truly humbling about NGC 4194 is how it defies our expectations. We often think of mergers as endpoints, the death knell for spiral galaxies as they morph into bland ellipticals. But the Medusa Merger shows us that these collisions are more like rebirths, violent, messy, but brimming with potential. It's a cosmic phoenix, turning its own destruction into the raw materials for new stars, new systems, and maybe even new worlds. And as we study it, we're forced to ask, If something this beautiful can emerge from chaos, what other wonders are hidden in the universe's most violent moments? The Sunflower Galaxy blooms in the cosmos with a delicate, almost ethereal beauty, a spiral so subtly structured it seems painted with the lightest brushstrokes of starlight. Officially known as Messier 63, this flocculent spiral in the constellation Canes Venatus lacks the bold, sweeping arms we associate with galaxies like the Whirlpool or Andromeda. Instead, its disk is a soft, mottled tapestry of short, fragmented spiral segments, giving it the appearance of a sunflower's golden petals scattered across the void. But don't mistake its gentle appearance for simplicity. The Sunflower Galaxy is a masterclass in cosmic complexity, defying the neat classifications astronomers once used to box spiral galaxies into tidy categories. What makes M63 so unusual is its lack of grand design, those pronounced symmetrical arms that dominate textbooks. Instead, its structure is a patchwork of star-forming regions, dust lanes, and loosely wound spirals, all shimmering with a golden hue from its older stellar populations. This flocculent pattern, meaning woolly or flaky, suggests a quieter, more disordered evolution compared to its bold-armed cousins. Unlike galaxies where density waves sculpt sharp spirals, the sunflower's arms are likely self-propagating, emerging from local instabilities in its disk. Imagine tossing pebbles into a pond, but instead of neat ripples, you get a shimmering, ever-shifting mosaic of tiny waves. That's the kind of dynamic chaos governing this galaxy's form. Yet hidden within its apparent softness lies a turbulent heart. Infrared observations reveal a hidden bar, a straight, dense structure of stars at its core, hinting that the sunflower might not be as relaxed as it seems. Bars are cosmic engines, funneling gas inward to fuel star formation or feed the central black hole. Here, it's likely stirring the galaxy's disk, creating the conditions for those flocculent arms to flicker in and out of existence. Even more intriguing, the sunflower is part of the M51 group, a small gathering of galaxies that includes the Whirlpool. While it's not colliding with its neighbors, their gravitational influence may have played a role in shaping its delicate structure, like a sculptor's light touch on clay. The real puzzle M63 poses is one of origins. Why do some spirals evolve into crisp, grand designs while others, like the sunflower, become flocculent? One theory points to gas content. Galaxies with less gas might lack the fuel needed to sustain sweeping arms, resulting in these fragmented patterns. Another suggests it's about turbulence. Too much random motion in the disk can prevent the orderly spiral waves from taking hold. Whatever the answer, the Sunflower Galaxy reminds us that even the most serene corners of the universe are laboratories of physics, where the interplay of gravity, gas, and time writes its own rules. Gazing at M63, we're not just seeing a pretty face. We're witnessing a challenge to our cosmic classifications, a galaxy that refuses to fit neatly into boxes. Its fragmented arms whisper secrets about the diversity of spiral structures, proving that even in the vastness of space, there's no one-size-fits-all blueprint for beauty. And as we study its petals of starlight, we're left wondering, if something this gentle can upend our expectations, what other cosmic surprises are waiting to bloom in the dark? The Silver Coin Galaxy gleams in the cosmos like a tarnished treasure tossed into the void, its edge on orientation, giving it the appearance of a slender celestial disk. Catalogued as NGC 253, this starburst galaxy in the constellation Sculptor isn't just another spiral. It's a maelstrom of creation and chaos, birthing stars at a rate that dwarfs our Milky Way by tenfold. From our vantage point, its dust-choked disk appears etched with dark filaments, as if some cosmic hand dragged a brush through its starry canvas. But these aren't mere shadows, they're the scars of a galaxy consuming itself in a firestorm of stellar rebirth. What makes NGC 253 truly extraordinary isn't just its star factories, it's the galactic-scale tempest they've unleashed. superheated gas blasted outward by supernova explosions and the fierce radiation of newborn stars has created a phenomenon astronomers call a superwind. Picture a hurricane, but one that spans tens of thousands of light years, hurling material into intergalactic space at millions of miles per hour. This isn't just a gentle breeze, it's a cosmic gale powerful enough to shape the galaxy's future, stripping away the raw materials needed for future stars and leaving behind a ghostly halo of ejected matter. Yet the silver coin galaxy's brilliance comes at a price. All that frenzied star formation is unsustainable, a fleeting boom that will eventually leave the galaxy starved of gas, its stellar nurseries running dry. The superwind is both creator and destroyer, sculpting breathtaking structures while sealing the galaxy's fate. X-ray observations reveal vast plumes of multimillion-degree gas arcing above and below the disk like the wings of some colossal phoenix. These aren't just remnants, they're evidence of the galaxy's violent metabolism, converting gas into stars and stars into oblivion at a breakneck pace. Adding to the intrigue is NGC 253's hidden engine, a supermassive black hole shrouded in dust, its presence betrayed only by faint radio emissions. Unlike the voracious monsters at the hearts of other galaxies, this one seems oddly subdued, as if the surrounding starburst has stolen its spotlight. Some astronomers speculate that the black hole's growth has been stifled by the very winds its galaxy has unleashed, a cosmic irony where stellar birth stifles the darkness at the center. But perhaps the most astonishing thing about the silver coin galaxy is how it defies isolation. Most starbursts are triggered by collisions, yet NGC 253 appears to be raging alone, its fury self-inflicted. One theory suggests it may have cannibalized smaller galaxies in the past, their gas reservoirs igniting this firestorm. Another possibility, the galaxy's structure slightly warped, as if tugged by an unseen force, hints at gravitational interactions we've yet to map fully. Whatever the cause, its brilliance makes it one of the few galaxies outside our local group visible through amateur telescopes, a shimmering reminder that the universe's most dazzling spectacles often hide the darkest mysteries. Studying NGC 253 is like watching a cosmic hourglass drain. Every brilliant young star, every wisp of superwind is a grain of sand marking time. It's a galaxy living fast and by cosmic standards dying young, offering us a front row seat to the explosive, ephemeral nature of starbursts. And as we trace the arcs of its superwind, we're left to wonder, when the last of its gas is spent and the stellar fires dim, what legacy will this silver coin of the cosmos leave behind? The mice galaxies are celestial dancers frozen in mid-step, their long, graceful tails stretching across the cosmos like twin brushstrokes of starlight. Officially catalogued as NGC 4676, this pair in the constellation Coma Berenices is locked in a gravitational embrace so slow, it makes glacial movement seem frantic. Their nickname comes from those spectacular tidal tails, each over 200,000 light-years long, streaming behind them like the tails of fleeing mice. But this isn't an escape, it's an inevitable spiral toward merger, a cosmic pas de deux that's been unfolding for hundreds of millions of years and will continue for hundreds of millions more. What makes the mice so mesmerizing isn't just their beauty, it's the physics etched into their wreckage. Those elegant tails aren't random debris, they're stellar highways packed with stars and gas ripped from the galaxy's disks by gravitational friction. As the mice circle each other, their mutual pull stretches their structures like taffy, with the trailing material forming these luminous arcs. Yet even as they tear each other apart, they're also seeding new creation. Within those tails, pockets of compressed gas collapse into star clusters, some so young they're still swaddled in the nebulae that birthed them. It's a paradox of destruction and rebirth. The same forces shredding these galaxies are also scattering the ingredients for future stars. But the real magic lies in what the mice reveal about cosmic evolution. Collisions like this aren't rare, they're the universe's primary architect. Most galaxies, including our Milky Way, bear scars of past mergers, their shapes sculpted by ancient crashes. The mice offer a snapshot of this process mid-stride, showing how gravity weaves chaos into order. Over time, their twin nuclei will merge, their tails fade, and the once spiral structures blur into a single elliptical galaxy, a fate that awaits nearly all interacting galaxies given enough time. Yet even in this predictable dance there's mystery. The mica's tails aren't symmetrical, one stretches farther and shines brighter than the other. This asymmetry hints at differences in the original galaxies. Perhaps one was richer in gas, or their collision angle wasn't perfectly aligned. Such details matter because they determine how mergers redistribute matter, not just within galaxies but into the intergalactic void. The mica's ejected stars may one day roam freely as rogue stars, untethered to any galaxy, while their expelled gas could seed future generations of star formation far from their origins. What's truly humbling is the scale of this transformation. The mice are separated by roughly 160,000 light-years, a distance that seems vast until you realize their gravitational bond spans millions more. Their dance isn't just reshaping them, it's altering the fabric of their local universe, proving that no galaxy is an island. Even as we watch from a safe distance, we're witnessing our own cosmic future, a preview of the Milky Way's eventual collision with Andromeda. The mice remind us that the universe isn't static. It's a living, breathing network of gravity's patient handiwork, where every collision writes a new chapter in the story of structure itself. The Tadpole Galaxy isn't just a cosmic oddity. It's a galactic crime scene, its long, luminous tail trailing behind it like the aftermath of a gravitational heist. Officially dubbed UGC 10214, this peculiar spiral in the constellation Draco stretches an astonishing 280,000 light-years from tip to tail, with its elongated stream of stars and gas accounting for nearly half its length. But this wasn't always its shape. The tadpole's dramatic metamorphosis began roughly 100 million years ago, when a smaller, intruder galaxy sideswiped it in a flyby encounter, a cosmic hit and run that sent shockwaves through its structure. The gravitational tug of war that followed didn't just warp the tadpole, it ripped entire stellar neighborhoods from their orbits, flinging them into intergalactic space in a glittering arc. What makes this galaxy so valuable to astronomers isn't just its striking silhouette, it's the forensic evidence embedded in that tail. Unlike the chaotic wreckage of head-on collisions, the tadpole's tail is a near-pristine snapshot of galactic harassment, a process where galaxies are reshaped by repeated gravitational encounters rather than full mergers. The tail's blue hue betrays its youth, packed with massive, short-lived stars born from gas compressed during the encounter. But hidden among them are older, redder stars, ancient refugees from the tadpole's disk ejected into the void. This mix of ages offers a rare timeline of the galaxy's disruption, like growth rings in a tree trunk. Even more fascinating is what the tail reveals about galactic survival. As the tadpole's stolen stars drift away, they're not just lost forever. Some may form isolated clusters or even dwarf galaxies, while others could be captured by passing galaxies, seeding new stellar populations far from their origins. Meanwhile, the tadpole's surviving core is no passive victim. Observations show its remaining gas is collapsing into new stars at a feverish pace, as if the galaxy is fighting to rebuild itself against the tide of destruction. This burst of creation isn't just a rebound, it's a testament to how violence can spark new life in the cosmos, but the real puzzle lies in the intruder's identity. Unlike the antennae or mice galaxies, where both colliding partners are visible, the tadpole's assailant has vanished without a trace. Was it a small, dim galaxy that slipped away unnoticed, or something stranger like a dark matter-rich subhalo whose gravity left scars without luminous evidence? The mystery underscores how much of galactic evolution might be driven by invisible actors, their presence inferred only by the wreckage they leave behind. Tadpole galaxies like UGC 10214 are cosmic Rosetta Stones, decoding the subtle language of gravitational encounters. They teach us that galaxies aren't just shaped by catastrophic mergers, but by countless smaller interactions, a slow, persistent sculpting that's just as transformative. And as we study this celestial tadpole's struggle to hold itself together, we're reminded that even in the vastness of space, no galaxy evolves alone. Every tale, every scar, is a verse in an epic poem of gravitational influence, one that's still being written across the night sky. NGC 1300 isn't just another spiral galaxy, it's a cosmic whirlpool with a secret engine humming at its core. This barred spiral, located 65 million light-years away in the constellation Eridanus, is so perfectly structured it could have been plucked straight from an astronomy textbook. Its arms unfurl in a graceful sweep, dusted with star-forming regions that glow like scattered embers. But the real showstopper is that bold, glowing bar slicing through its center, a dense, elongated structure of stars and gas stretching over 30,000 light-years. This isn't mere decoration, it's a gravitational conveyor belt, shuttling matter toward the galaxy's heart in a relentless cycle of creation. The bar's role in NGC 1300's evolution is nothing short of transformative. Like a cosmic sluice gate, it channels gas inward from the galaxy's outer regions, compressing it into dense clouds as it funnels toward the core. This compression ignites bursts of star formation along the bar's length, painting it with clusters of young blue stars. But here's the twist. Unlike many barred spirals, NGC 1300 lacks an active supermassive black hole at its center. Its core is eerily quiet, a puzzle for astronomers who expected all that incoming gas to fuel a monstrous gravitational beast. Instead, the galaxy seems to be stockpiling its resources, perhaps biding its time before a future outburst or challenging our assumptions about how bars and black holes interact. What makes this galaxy especially fascinating is the intricate structure within its bar. High-resolution images reveal delicate spiral patterns nested inside the central bar itself, a bar within a bar phenomenon that suggests even deeper layers of gravitational choreography. These mini-spirals may act as secondary channels, further refining the flow of gas toward the nucleus in a cosmic game of pinball. Meanwhile, the outer arms, though stunning, are relatively quiescent, their star formation muted compared to the bar's fervent activity. This stark contrast turns NGC 1300 into a living laboratory for studying how galactic substructures redistribute energy and matter. But the galaxy's serene beauty hides a ticking clock. Bars aren't permanent, they're dynamic features that can dissolve over billions of years as their orbits destabilize. Some simulations suggest bars may even dissolve and reform in cyclical bursts like a celestial heartbeat. For now, NGC 1300's bar is in its prime, a master regulator balancing star birth and material transport with exquisite precision. It stands as a testament to the elegance of galactic evolution, proof that even in the chaos of the cosmos, gravity can sculpt structures of breathtaking order. And as we study its quiet core and bustling bar, we're left to wonder, is this what our own Milky Way might look like from afar, its own central bar silently shaping its destiny? NGC 5128, better known as Centaurus A, is the cosmic equivalent of a Frankenstein's monster, a galaxy stitched together from mismatched parts that somehow works. At first glance, it defies classification, with the bulky, star-packed body of an elliptical galaxy crossed with the dark, slashing dust lane of a spiral. But this bizarre hybrid isn't just a celestial oddity. It's a powerhouse of violent activity, home to one of the most energetic supermassive black holes in our galactic neighborhood. That iconic dust belt, spanning over 60,000 light-years, isn't some peaceful ribbon, it's a war zone of star formation, shredded by shockwaves from the galaxy's turbulent past. The real jaw-dropper lies at Centaurus A's heart, an active galactic nucleus so ferocious it shoots relativistic jets of plasma hundreds of thousands of light-years into space. These jets aren't gentle beams, they're supersonic freight trains of particles, accelerated to nearly the speed of light by the black hole's unimaginable gravity. One jet points straight at Earth, giving astronomers a rare front-row seat to the physics of these cosmic particle cannons. Radio telescopes reveal the jet's structure in staggering detail, lumpy, twisted, and prone to violent flares as magnetic fields snap and reconnect like cosmic rubber bands. What's startling is how persistent these jets are, enduring for millions of years despite the chaos around them. But Centaurus A's violence isn't just about its black hole. That jagged dust lane tells a darker story, a galactic cannibalism event roughly 100 million years ago when this giant devoured a smaller spiral galaxy. The collision didn't just leave scars, it funneled vast amounts of gas toward the center, feeding the black hole's outbursts and igniting starbursts along the dust lane's edges. Today, the galaxy is littered with the debris of that meal, streams of orphan stars, globular clusters ripped from the victim, and ghostly shells of stars recoiling from the impact like ripples in a pond. What makes Centaurus a truly unique is how it bridges galactic categories. Most elliptical galaxies are red and dead, their star-forming gas long exhausted. Yet here, dust and gas rage on, making it a rare, young elliptical. Some astronomers speculate it's caught mid-transformation, a spiral being remodeled by mergers into a smooth elliptical, frozen in the act. Others see it as proof that ellipticals can retain or acquire fresh gas, challenging old assumptions about galactic evolution. Then there's the invisible hand shaping it all, dark matter. Measurements of Centaurus A's outer stars reveal a halo far more massive than visible matter can explain, its gravity sculpting the paths of dwarf galaxies around it like puppets on strings. This hidden architecture may hold clues to how such monstrous galaxies anchor their corners of the universe. Studying Centaurus is like watching a cosmic lab experiment unfold. Its jets probe intergalactic space, its dust lane archives past violence, and its very existence questions how galaxies mature. At just 13 million light-years away, it's close enough to scrutinize in intimate detail, a reminder that the universe's most brutal and beautiful dramas are happening right in our backyard. NGC 6782 and NGC 7217 might both wear rings, but they couldn't be more different. One flaunts a sparkling outer loop of newborn stars, while the other hides a cryptic inner band that defies easy explanation. These two galaxies are cosmic opposites, their structures challenging the tidy narratives astronomers once held about how ringed galaxies form. Take NGC 6782 first, a barred spiral in the constellation Pavo that looks like it's dressed for a celestial gala. Its most striking feature is a brilliant outer ring, a hoop of young, blue stars and pink hydrogen gas that glows with the frenzy of ongoing star formation. But here's the twist, this dazzling ring isn't a static ornament. It's a galactic traffic jam where gas piles up as it's funneled inward by the galaxy's central bar. Like water hitting a dam, the material stalls at a gravitational resonance point, a region where the bar's rotation syncs up with the orbits of stars and gas, creating a pressure wave that triggers bursts of starbirth. The result, a luminous, star-studded loop that's essentially a cosmic conveyor belt caught in the act. Yet NGC 6782 isn't just a one-trick wonder. Peek closer and you'll spot a second, fainter inner ring near its core, a ghostly echo of the same process on a smaller scale. It's a galactic matryoshka doll with nested rings telling layers of its history. Now shift your gaze to NGC 7217, a spiral in Pegasus that flips the script entirely. Unlike its outer ringed counterpart, this galaxy's most puzzling feature is an inner ring, a tight, shimmering circle of stars nestled close to its nucleus far from the spiral arms. Stranger still, this ring isn't forming new stars. Instead, it's packed with older, yellower stars, their light hinting at a quieter, more mysterious origin. Some astronomers suggest this ring might be a relic of a past merger, a ripple frozen in time from when another galaxy brushed too close and sent stars swirling into this unusual configuration. Others propose it's the work of a long-gone bar that dissolved, leaving behind this stellar snapshot like a fossilized imprint. But the real enigma, NGC 7217's outer regions are almost suspiciously calm. No grand spiral arms, no bursts of star formation. It's as if the galaxy's entire personality condensed into that cryptic inner ring, leaving the rest to fade into the background. What makes these two galaxies so revolutionary isn't just their contrasting looks, it's how they break the mold of galactic evolution. Ringed galaxies were once thought to form primarily through collisions, like the Cartwheel galaxy's bullseye. But NGC 6782 and NGC 7217 prove rings can emerge from internal processes too, with no cosmic crash required. One thrives on the dynamism of its bar, the other whispers of ancient gravitational disturbances we're only beginning to decipher. Together, they're a masterclass in diversity, showing that the universe often prefers multiple blueprints even for something as seemingly simple as a ring. Studying these galactic opposites forces us to rethink how structure emerges in the cosmos. Are inner rings fossilized records of past violence, or do they mark zones where gas simply couldn't settle? Do outer rings always trace the footsteps of bars, or can they form through other means? Every observation peels back another layer, revealing just how much we still have to learn about the universe's architectural quirks. And as we compare NGC 6782's starry hoop to NGC 7217's silent inner loop, we're reminded, sometimes the most profound lessons come not from the grandest phenomena, but from the quiet contradictions hiding in plain sight. NGC 3314 isn't just two galaxies, it's a cosmic magic trick, a celestial illusion where one spiral appears to melt straight through another. Nestled in the constellation Hydra, this rare alignment places a face on Spiral Galaxy almost perfectly in front of a larger, edge-on one, like a ghostly hand passing through a spinning coin. From our vantage point, the foreground galaxy's dust lanes and star clusters seem superimposed onto the backdrop of its neighbor, creating a surreal transparency effect that defies intuition. But this isn't just a visual curiosity. It's a golden opportunity for astronomers to decode one of the universe's most elusive ingredients, interstellar dust. What makes this pairing so invaluable is the way it turns the foreground galaxy into a backlit stencil. By analyzing how the background galaxy's light filters through the overlapping spiral, scientists can map the dust distribution in the foreground with unprecedented precision. Dust might seem like a minor detail, but it's the dark scaffolding of star formation, the raw material that clumps together to birth new solar systems. Yet traditionally, dust has been notoriously hard to study because it absorbs and scatters light, hiding its own structure. Here, the background galaxy acts like an X-ray, revealing not just where the dust is, but how it behaves. The darker patches aren't empty voids, they're dense clouds of carbon and silicate grains, some no larger than smoke particles, blotting out the light behind them like cosmic ink blots. But the real revelation lies in the shadows. Some regions of the foreground galaxy appear fainter than expected, suggesting its dust isn't evenly distributed instead. It's clumped into intricate filaments and tendrils woven through the spiral arms like a spiderweb. This challenges older models that assumed dust spread smoothly across galaxies. Even more striking, the dust's filtering effect changes with wavelength. In ultraviolet light, the foreground galaxy looks almost opaque but shifts to infrared, and it becomes semi-transparent, revealing how different sizes of dust grains interact with light. It's like watching the same scene through multiple stained glass windows, each pane revealing new layers of detail. Yet NGC 3314's greatest gift might be what it teaches us about galactic evolution. The background galaxy's distorted shape hints it's not entirely unaffected by its partner. Subtle tidal forces may be warping its structure, a reminder that even seemingly isolated galaxies live in a web of gravitational relationships. Meanwhile, the foreground galaxy's dust lanes show signs of recent star formation, their chemistry altered by supernova explosions. Together, they paint a dynamic portrait of galaxies as ever-changing entities, not static islands in space. This cosmic overlap is more than a pretty picture. It's a natural laboratory, a chance to study processes we could never replicate on Earth. And as astronomers continue to peel back its layers, they're uncovering truths about how galaxies build their intricate architectures one dust grain at a time. The universe often hides its secrets in plain sight, but sometimes it lines up the pieces just right, offering us a fleeting glimpse behind the curtain. NGC 1365 isn't just another barred spiral, it's a cosmic guillotine, where a supermassive black hole feasts in violent, rhythmic bursts, as if the universe itself has a case of celestial indigestion. This stunning galaxy in the constellation Fornax is a masterpiece of spiral structure, its arms sweeping outward from a golden bar like ribbons unfurling in zero gravity. But the real drama unfolds at its core, where a black hole weighing nearly 2 million suns isn't just eating its binge-eating with the regularity of a metronome, flaring brightly every few days before fading back into silence. These aren't random outbursts, they're clockwork hiccups offering astronomers a front-row seat to one of the universe's most enigmatic processes, how black holes devour their meals. What makes these hiccups so revealing is their precision. Most supermassive black holes feed erratically, flaring unpredictably as they rip apart stars or gulp down gas clouds. But NGC 1365's black hole seems to operate on a schedule, its X-ray emissions spiking like a heartbeat. One theory suggests this regularity stems from the way matter swirls into the black hole's maw. Instead of flowing smoothly, gas might clump into dense knots, orbiting in a lopsided disk that tilts and wobbles like a spinning top losing momentum. Every time one of these clumps plunges past the event horizon, it unleashes a burst of energy, a cosmic burp echoing across the electromagnetic spectrum. But here's the puzzle, these hiccups shouldn't last. Under normal conditions, friction and gravity should smooth out the clumps, rendering the disk uniform within months. The fact that this black hole keeps hiccuping implies something, or someone is restocking the buffet. That's where NGC 1365's magnificent bar comes into play. This star-studded structure acts like a conveyor belt, funneling fresh gas toward the inner galaxy at a staggering rate. The bar's gravitational torque strips gas clouds of their angular momentum, sending them spiraling inward to replenish the black hole's lopsided disk. It's a self-sustaining cycle. The bar feeds the hiccups, and the hiccups reveal how the bar operates. Yet the implications stretch far beyond this single galaxy. If NGC 1365's black hole is a messy eater, others might be too, just on scales we've yet to detect. These rhythmic flares could explain similar phenomena observed in distant quasars, where supermassive black holes flicker like cosmic strobe lights. The galaxy's bar might also hold clues to why some black holes feast while others starve. In galaxies without bars, gas often orbits aimlessly, never getting close enough to the center to fuel outbursts. But in barred spirals like this one, the architecture itself forces matter into the danger zone, turning quiet black holes into active monsters. What's truly humbling is how much we still don't know. Why do some clumps survive the journey intact while others dissipate? Could magnetic fields be shaping the disk's tilt, or is another force at play? Every hiccup from NGC 1365's black hole is a data point, a whisper from the edge of spacetime about how gravity behaves under extreme conditions. And as we decode these signals, we're not just learning about one galaxy, we're piecing together the dietary habits of black holes across the cosmos, one rhythmic gulp at a time. NGC 6240 isn't just a galaxy, it's a cosmic battlefield. Its delicate butterfly wings stretched wide in the aftermath of a collision too brutal for most spirals to survive. Located 400 million light-years away in the constellation Ophiuchus, this chaotic beauty is the wreckage of two galaxies that smashed together head-on, their stars and gas now swirling in a turbulent dance of creation and destruction. But what sets NGC 6240 apart isn't just its haunting silhouette. It's the secrets lurking in its heart, not one, but two supermassive black holes locked in a gravitational waltz that will one day shake the fabric of spacetime itself. These aren't just any black holes, each is a behemoth, weighing in at hundreds of millions of solar masses, spinning and feeding just 3,000 light-years apart. To put that in perspective, that's closer than Earth is to the center of our own Milky Way. Their proximity is a ticking time bomb. Eventually, they'll spiral together in a merger so violent, it will send gravitational waves rippling across the universe. For now, though, they orbit each other like prizefighters circling the ring, their combined gravity stirring the surrounding gas into a frenzy. X-ray observations reveal them shrouded in thick clouds of dust, their radiation so intense it punches through the galaxy like a flashlight beam through fog. But the real spectacle is what their chaos has unleashed. The collision compressed vast reservoirs of gas, igniting a starburst so ferocious, NGC 6240 churns out new stars at a rate 50 times faster than the Milky Way. The entire galaxy glows with the fire of infant stars, their ultraviolet radiation lighting up surrounding dust clouds like neon signs. Infrared telescopes peer through the haze to reveal clusters of superstar clusters, dense knots of young stars so packed together they rival the cores of dwarf galaxies. Some of these stellar nurseries are less than 10 million years old, cosmic newborns in a galaxy that's essentially rebuilding itself from the wreckage. Yet for all this rebirth, NGC 6240 is a galaxy living on borrowed time. The same starburst that lights it up is also exhausting its fuel, and the twin black holes are carving out cavities in the surrounding gas, their jets and radiation pushing star-forming material away. In a few 100 million years, the fireworks will fade, the black holes will merge, and what remains may resemble an elliptical galaxy, smooth, quiet, and utterly transformed. What makes this galaxy so extraordinary is how it defies simple classification. It's not just a merger remnant, it's a snapshot of a pivotal moment in galactic evolution, a laboratory for studying how black holes co-evolve with their hosts, and a preview of what might happen when our own Milky Way collides with Andromeda billions of years from now. Every flicker of its starburst, every twist of its black hole's dance, is a clue to the universe's most violent and creative processes. And as we watch, we're reminded that even in destruction, there's beauty, and in chaos, the seeds of new beginnings. NGC 1275 and NGC 1277 might share catalogue numbers, but they're celestial opposites, one a stormy giant anchoring a galaxy cluster, the other a frozen relic from the universe's infancy. Their differences aren't just cosmetic, they're rewriting the rulebook on how galaxies live and die. Take NGC 1275 first, the unruly heart of the Perseus cluster. This galaxy isn't just living in a crowded neighborhood, it's dominating it, sitting at the center of a cosmic maelstrom where gravity and superheated gas collide. What makes this galaxy so extraordinary isn't just its size, it's the way it's actively reshaping its surroundings. Filaments of cool gas, some stretching 20,000 light-years, spiral outward from its core like cosmic tendrils, defying the blistering heat of the surrounding cluster plasma. These delicate structures shouldn't survive in such a hostile environment, yet they do, held together by magnetic fields as strong as steel cables. At the galaxy's core, a supermassive black hole pumps energy into the system like a cosmic engine, its jets inflating enormous bubbles of radio-emitting plasma that rise through the cluster gas like balloons in molasses. The result, a feedback loop of violence and order, where the black hole's outbursts prevent the galaxy from growing too large by heating and dispersing nearby gas. It's a self-regulating system, a celestial thermostat that challenges our assumptions about how galaxies evolve in clusters. Now shift your gaze to NGC 1277, a galactic time capsule drifting just 73 million light-years away. Unlike its turbulent counterpart, this compact galaxy hasn't formed new stars in over 10 billion years. It's a relic preserved almost perfectly from the early universe, but with one shocking feature. A supermassive black hole accounting for nearly 14% of the galaxy's total stellar mass lurks in its core. To put that absurd ratio in perspective, our Milky Way's central black hole weighs less than 1% of the bulge stars around it. This discovery turned astronomy on its head. According to conventional models, black holes and their host galaxies grow in lockstep, but NGC 1277's monster suggests some black holes might have formed first, with galaxies assembling around them like scaffolding. The galaxy's ancient, quiescent stars support this idea. They're packed so tightly, their collective gravity would have funneled gas straight to the black hole early on, starving future star formation. Together, these two galaxies are stress-testing our theories of galactic life cycles. NGC 1275 shows us how environment shapes evolution, with its black hole actively sculpting both its host galaxy and the surrounding cluster. Meanwhile, NGC 1277 whispers secrets from the cosmic dawn, hinting at an era when black holes might have called the shots before galaxies even knew how to grow up. One thrives in chaos, the other in stasis, yet both are rewriting the story of how structure emerges in the universe. And as we study them, we're forced to ask, are these outliers, or have we been missing fundamental chapters in the galactic playbook all along? NGC 4151 isn't just a galaxy. It's a cosmic strobe light, flickering with the erratic pulse of a supermassive black hole caught in the act of feeding. Nicknamed the Eye of Sauron for its uncanny resemblance to Tolkien's fiery villain, this spiral galaxy in Canes Venatus has been keeping astronomers on their toes for decades. Its nucleus doesn't just glow steadily, it flares and dims unpredictably, sometimes doubling in brightness within days before fading back into obscurity. This isn't just random noise, it's a window into one of the universe's most enigmatic phenomena, the chaotic dining habits of active galactic nuclei. What makes NGC 4151 so fascinating isn't just its variability, it's the scale of the tantrums. The black hole at its center, weighing in at around 50 million solar masses, isn't just swallowing gas quietly. It's devouring in violent fits and starts, with flares so intense they outshine the galaxy's billions of stars combined. X-ray observations reveal the drama in gruesome detail. Clumps of gas, heated to millions of degrees, spiral toward the event horizon before vanishing in bursts of energy. But here's the puzzle. These outbursts don't follow a neat timeline. Some last weeks, others mere hours, as if the black hole can't decide whether to feast or fast. The secret might lie in the galaxy's unique feeding mechanism. Most active galactic nuclei draw gas from orderly accretion disks, but NGC 4151's black hole appears to be snacking on a jumbled buffet. Turbulent inflows of gas, possibly triggered by recent interactions with neighboring galaxies, crash into the disk at odd angles, creating pockets of instability. Imagine trying to eat a meal while someone keeps shaking the table. That's the chaotic environment fueling this black hole's flickering appetite. Even more intriguing, the flares aren't uniform across wavelengths. Ultraviolet spikes might precede X-ray bursts by days, hinting at shockwaves rippling through the accretion disk like cosmic dominoes. Yet the real treasure isn't just the black holes' tantrums, it's what they reveal about active galaxies as a class. NGC 4151 sits at a sweet spot, close enough 45 million light-years to study in detail, yet active enough to mirror the behavior of quasars billions of light-years away. By decoding its flickers, astronomers are piecing together how all AGN regulate their energy output. Some theories suggest magnetic fields, twisted by the black hole's spin, act like cosmic valves, releasing energy in explosive bursts. Others point to instabilities in the disk itself, where gas piles up until it collapses inward in sudden avalanches, but the galaxy's drama extends beyond its core. Its spiral arms, though picturesque, show signs of gravitational turmoil, knots of star formation, and distorted dust lanes suggesting past encounters with smaller galaxies. These interactions might have funneled fresh gas toward the center, reigniting the black hole's activity after eons of quiet. It's a reminder that AGN aren't isolated monsters, they're deeply connected to their host galaxies' life stories. NGC 4151's greatest lesson might be about perception. From afar, it's a shimmering spiral, serene as any other. But peer closer, and you find a maelstrom of chaos, a black hole's feast rendered in strobe light flashes. It challenges us to rethink how we classify active galaxies, not as static on or off states, but as dynamic, ever-shifting systems where even the mightiest objects are at the mercy of their last meal. And as we watch its nucleus flicker like a candle in the cosmic wind, we're left to wonder, is this what all AGN look like when studied up close, or is the eye of Sauron blinking its secrets at us alone? NGC 3079 isn't just another edge on spiral, it's a galactic pressure cooker, venting its fury through two monstrous superbubbles that tower 4,500 light-years above its disk like cosmic smokestacks. These aren't your average stellar bubbles, they're titanic structures of superheated gas, erupting from the galaxy's core at speeds that defy imagination, stretching so far they could swallow our entire solar system 1,000 times over. What makes these bubbles so extraordinary isn't just their scale, it's the raw violence of their birth. Unlike the gentle inflation of a soap bubble, these colossi were forged in the furnace of non-stop supernova and screaming stellar winds, their energy equivalent to millions of suns detonating in unison. Peer closer, and the mechanics of this galactic exhaust system become even more startling. The bubble's walls glow fiercely in X-rays, a telltale sign of gas heated to millions of degrees temperatures so extreme, atoms are stripped bare of their electrons. This isn't just hot gas, it's plasma in its most frenzied state, a roiling soup of charged particles that crackles with magnetic turbulence. Yet within this maelstrom lies a paradox. Nestled along the bubble's rims are delicate filaments of cooler gas, like dew forming on the rim of a steam vent. These filaments shouldn't survive in such a hostile environment, yet they thrive, revealing how chaotic energy can sculpt unexpected order. The real magic, though, lies in how these superbubbles shape their galaxy's destiny. As they expand, they act like cosmic bellows, pumping energy and heavy elements forged in supernova out into the galactic halo. This isn't just waste heat, it's star fuel, expelled so violently it might never fall back to the disk. That means NGC 3079 isn't just blowing off steam. It's potentially starving its future self, limiting how many new stars it can form. Some simulations suggest these outflows could even regulate a galaxy's growth, preventing it from becoming too massive too quickly. It's a self-regulating mechanism where the very violence of star formation puts the brakes on further excess. Yet for all their destructive power, these bubbles might also be galactic architects. Where their shockwaves collide with surrounding gas, they compress molecular clouds into dense knots, triggering fresh rounds of star formation even as they quench it elsewhere. It's a breathtaking contradiction. The same forces that stifle star birth in one region can ignite it in another, painting the galaxy with brushstrokes of both creation and destruction. What makes NGC 3079 truly humbling is how it mirrors processes seen across the universe, from starburst galaxies to the earliest cosmic structures. Its superbubbles offer a local lab for studying how galaxies recycle their matter, how energy flows between their disks and halos, and how even the most violent events can sculpt beauty from chaos. And as we watch these colossal structures rise and fade over millions of years, we're left with a profound realization: galaxies aren't just collections of stars. They're dynamic, breathing entities where every explosion, every outflow, writes another line in an endless story of transformation. NGC 4314 isn't just a barred spiral, it's a cosmic bullseye with a ring of fire blazing so fiercely around its core, it outshines the rest of the galaxy combined. This peculiar structure in Coma Berenices isn't forming stars evenly across its arms like most spirals. It's funneling nearly all its stellar birth into a single, luminous hoop just 3,000 light-years from its center. The result, a dazzling circumnuclear starburst ring, where clusters of young, blue stars burn with such intensity, they drown out the galaxy's quieter outer regions in a blaze of ultraviolet light. But this isn't just a random fireworks display, it's a masterclass in how galactic architecture can dictate where and how stars are born. The secret to this ring's existence lies in the galaxy's bar, that long, straight structure of stars slicing through its core. Bars act like cosmic conveyor belts, dragging gas inward through gravitational torque. But in NGC 4314, something extraordinary happens. The gas doesn't plunge straight into the center. Instead, it piles up at a specific resonance point where the bar's rotation speed matches the orbital speed of material in the disk. This creates a traffic jam of matter, compressing gas clouds until they collapse into stars in a frenzied, localized burst. It's as if the galaxy has built a circular runway for star formation, with every incoming gas cloud forced to land and ignite at the same celestial airport. Yet the real puzzle isn't just how this ring formed, it's why the star formation hasn't spread outward. Most starbursts, like those in the Antennae Galaxies, scatter star birth across vast regions. Here, though, the action is bizarrely confined, as if some invisible barrier prevents the stellar fire from spreading. One clue comes from the ring's chemistry. Observations reveal it's rich in complex molecules like hydrogen cyanide, which thrive in dense environments. This suggests the ring isn't just a passive structure. It's a self-sustaining engine where supernova shocks from newborn stars keep compressing nearby gas, triggering yet more star formation in a feedback loop of creation. Adding to the intrigue is the galaxy's unusually quiet core. Despite all that gas being funneled inward, the central supermassive black hole remains dormant, a sleeping giant surrounded by this maelstrom of stellar birth. Some astronomers speculate the ring acts as a buffer, siphoning off so much material that the black hole goes underfed. Others think the black hole's inactivity might actually be enabling the starburst, as without disruptive jets or radiation, gas can cool and collapse into stars more efficiently. It's a delicate balance, one that challenges our assumptions about how galaxies regulate their growth. What makes NGC 4314 truly remarkable is its rarity. While many barred spirals have nuclear rings, few display starbursts this intense or this isolated. It's possible we're catching this galaxy in a fleeting phase, a brief window where the bar's resonance aligns perfectly with the gas supply, creating conditions ripe for a fireworks show that might last only a few 100 million years. Over time, as the gas depletes or the bar weakens, the ring could fade, leaving behind a quieter, more ordinary spiral. Studying this galaxy is like stumbling upon a controlled experiment in star formation. Its stark contrast between a frenetic core and serene outskirts offers clues about how gas moves, stacks, and ignites in barred systems. And as we unravel its secrets, we're forced to ask, Is this how our own Milky Way might look if its central bar triggered a similar resonance? Or is NGC 4314 a cosmic outlier, a reminder that even the most elegant galactic rules have exceptions? Either way, it stands as proof that sometimes the universe's most dazzling shows play out in the smallest of rings. NGC 4650 and NGC 6028 might both wear rings, but their similarities end where their orbits begin. These polar ring galaxies, cosmic oddities where hoops of gas and stars orbit at right angles to the main galaxy's disk, are celestial acrobats defying gravity's usual rules. Yet how they perform their balancing act tells two very different stories of galactic survival. Take NGC 4650 first, a spectacular hybrid in Centaurus that looks like a celestial hula hoop caught mid-spin. Its luminous ring, stretching over 50,000 light-years, rotates perpendicular to the central lenticular galaxy's plane, a configuration so improbable it seems to defy physics. But this isn't just a pretty illusion, it's forensic evidence of a cosmic hit and run. The leading theory, a smaller galaxy rich in gas, once plunged straight through the larger galaxy's disk like a bullet through a dartboard. The violent encounter stripped the victim of its material, leaving behind a swirling belt of debris that gradually settled into this striking polar orbit. What's astonishing is how orderly the wreckage appears. The ring's blue tint reveals clusters of young stars, proof that stolen gas didn't just linger. It thrived, collapsing into new stellar generations even as it whirled in this gravity-defying dance. Now contrast that with NGC 6028, a polar ring galaxy in Hercules that's practically a fossil. Its ring is fainter, redder, and packed with older stars, suggesting a merger so ancient the fire of star formation has long since burned out. Unlike NGC 4650A's vibrant loop, this ring feels like a ghostly remnant, a whisper of violence from the universe's rowdier youth. Yet here's the twist: its central galaxy isn't a flattened disk but a rounded elliptical, hinting at multiple mergers that erased all traces of its original structure. The ring might be the last surviving witness to that chaos, a celestial fingerprint left behind after the main event faded into history. What makes these galaxies revolutionary isn't just their shape, it's what they reveal about galactic diets. Polar rings are cosmic receipts, proving galaxies grow by swallowing their neighbors whole. NGC 4650 shows us the aftermath fresh, with star formation still crackling in the stolen material. NGC 6028, meanwhile, is the cold case demonstrating how even the most dramatic mergers fade into the background over billions of years. Together, they bookend the life cycle of galactic collisions, offering snapshots from violent adolescence to quiet old age, but the real magic lies in their stability. A ring orbiting at 90 degrees should be unstable, yet these structures persist for eons. The secret dark matter. Simulations suggest the invisible halos surrounding these galaxies act like gravitational glue, stabilizing the rings against disruption. Without it, these cosmic hula hoops would unravel into the void. Studying these polar ring galaxies is like stumbling upon a celestial crime scene where the evidence hasn't faded. They challenge our assumptions about angular momentum, gas dynamics, and how galaxies assemble themselves over time. And as we compare NGC 4650A's starry hoop to NGC 6028's fading relic, we're reminded the universe doesn't just build, it repurposes, leaving behind glittering clues to its chaotic past. NGC 7742 hangs in the cosmos like a celestial pearl necklace, its perfect hoop of starlight encircling a golden core with such geometric precision. It looks crafted by cosmic jewelers. This face-on spiral in Pegasus is more than just photogenic. It's a galactic enigma where a luminous inner ring glows with such intensity, it outshines the galaxy's faint outer arms entirely. But this isn't just a decorative feature, it's a gravitational crime scene, a smoking gun pointing to a violent past. The ring's sapphire blue clusters and pink hydrogen clouds betray a frenzy of star formation, with newborn stars burning so hot they're practically screaming for attention. Yet the real mystery lies in why this firestorm is so tightly confined to a narrow band, as if the galaxy drew a bullseye around its heart and set it ablaze. The secret to this ring's existence may be written in the stars, literally. NGC 7742's elegant structure suggests it was once a normal spiral until a smaller galaxy plunged straight through its disk like a bullet through fog. The intruder's gravity would have sent shockwaves rippling through the gas-rich plane, compressing material into a dense, circular wave that ignited star formation as it spread outward. But here's the twist. Unlike the Cartwheel Galaxy's sprawling ring, this one stayed compact, possibly because the collision was more of a glancing blow. The result is a starburst so concentrated, it's as if someone took a cosmic blowtorch to the galaxy's inner regions and left the outskirts untouched. What makes this galaxy truly bizarre is how its core defies expectations. Most galaxies with nuclear rings host supermassive black holes feasting on the inbound gas, but NGC 7742's center is oddly quiet. Infrared observations reveal no signs of the violent accretion or jets typical of active nuclei. Instead, the black hole seems to be fasting, its hunger overshadowed by the ring's stellar fireworks. One theory suggests the collision's geometry was just right to funnel gas into the ring but not the center, leaving the black hole stranded in a celestial desert while its surroundings feast. Yet the ring's brilliance comes with an expiration date. The same young stars lighting it up are also sealing its fate. Their fierce radiation and supernova explosions are blowing away the remaining gas, ensuring this starburst will eventually starve itself. Already, the ring shows signs of unevenness, with some segments brighter than others, hinting at patches where the fuel has run dry. In a few 100 million years, the pearls may fade, leaving behind a more ordinary spiral with only the whispers of its explosive past. NGC 7742 is more than a pretty anomaly. It's a masterclass in galactic cause and effect. Its perfect ring demonstrates how a single, well-placed collision can reshape a galaxy's destiny, turning a quiet spiral into a temporary beacon of stellar birth. And as we study its delicate balance of creation and destruction, we're left to wonder how many other galaxies wear the hidden scars of past mergers, their stories written in rings we've yet to discover. NGC 2685 doesn't just spin its spirals, its multiple disks twisting around each other like celestial ribbons caught in a cosmic whirlwind. Known as the Helix Galaxy, this bizarre structure in Ursa Major is one of the rarest sights in the universe, a polar ring galaxy with not one, but several misaligned disks of stars, gas, and dust, all orbiting at harsh angles to one another. From a distance, it looks like a galaxy trapped inside a galactic hamster wheel, its central bulge encased by a glowing, perpendicular hoop. But this isn't just a quirk of perspective. It's a gravity-defying balancing act that challenges everything we know about galactic stability. The chaos begins with the galaxy's most striking feature, its polar ring, a luminous band of stars and gas spinning over the poles of the main disk, rather than around its equator like Saturn's rings. Normally, such a structure would tear itself apart within a few 100 million years, yet NGC 2685's ring has endured for billions. The secret? Sheer pandemonium. Unlike orderly spirals where gas orbits in a single plane, this galaxy's multiple disks interact, their gravitational tugs creating zones of turbulence that somehow, against all odds, prevent the system from flying apart. Imagine spinning a dinner plate on a stick while simultaneously twirling a hula hoop around it at a right angle. Now add another hula hoop tilted at 45 degrees. That's the level of celestial acrobatics happening here. But the real puzzle isn't just the ring's existence, it's the galaxy's other misaligned features. Deep imaging reveals a second, fainter disk tilted relative to both the main galaxy and the polar ring, along with gas clouds orbiting in yet another plane. This isn't a single collision's aftermath. It's a layered history of cosmic violence, like a galactic palimpsest where each new merger left its mark. One theory suggests NGC 2685 cannibalized multiple smaller galaxies over eons, with each victim's gas settling into a new misaligned disk as it was torn apart. Another proposes that a close encounter with a massive neighbor warped the galaxy's original disk, bending it into these chaotic orientations. What's truly astonishing is how this mess works. Turbulence should lead to collapse, yet the helix galaxy thrives. The answer might lie in dark matter. Its invisible halo could act like a gravitational scaffold, stabilizing the system by anchoring the disk's wild motions. Or perhaps the disks themselves generate feedback, their collisions creating shock waves that redistribute energy and prevent any single structure from dominating. Radio observations add another clue. The polar ring is still forming stars, its gas compressed by the very forces that should destroy it. This isn't a dying galaxy, it's a laboratory of perpetual reinvention where chaos fuels creation. NGC 2685's greatest lesson is one of perspective. We often think of galaxies as orderly spirals or smooth ellipticals, but the universe has a flair for rebellion. Some structures refuse to play by the rules, bending physics until it accommodates their chaos. And as we study this galactic helix, we're forced to ask, is this an outlier, or are we just beginning to see the universe's true diversity? After all, if something this unstable can endure, what other gravitational wonders might be hiding in the dark? NGC 1132 isn't just a galaxy, it's a cosmic ghost town, a colossal elliptical drifting in eerie solitude like the last survivor of a forgotten era. Dubbed the Fossil Galaxy, this behemoth in the constellation Eridanus dominates its patch of space with unnerving emptiness, its nearest neighbors so distant they might as well be on another plane of existence. Most galaxies this massive sit at the heart of bustling clusters, surrounded by swirling satellites and hot gas. But NGC 1132, it's a titan standing alone, its dark matter halo strangely sparse, as if the universe forgot to pack its gravitational punch. What makes this galaxy so baffling isn't just its isolation, it's the paradox of its size. Elliptical galaxies usually grow by gorging on smaller neighbors, their bulk a testament to a lifetime of cosmic cannibalism. Yet here's NGC 1132, weighing in at nearly 10 trillion suns with no visible evidence of its past meals, no tidal streams of stolen stars, no shell-like remnants of devoured dwarfs, just a smooth, featureless glow stretching over 500,000 light-years. It's as if this galaxy fully formed, a celestial Athena springing from the void without the messy collisions that typically sculpt giants. The plot thickens when we peer at its dark matter. Most galaxies this massive are cocooned in vast, invisible halos, gravitational scaffolds that hold their stars in place and trap nearby victims. But NGC 1132's halo is oddly anemic, with far less dark matter than models predict. X-ray observations reveal another clue. The galaxy swims in a faint pool of hot gas, but even this is too tenuous for its size. Normally, such gas would be heated to millions of degrees by the gravitational crush of a hefty dark matter halo. The lack of both suggests something fundamental about this galaxy's formation defies the usual rules. One theory whispers of an ancient tragedy, a once thriving group of galaxies that merged so thoroughly all traces of the feast were erased. Imagine a cosmic Pac-Man consuming every morsel until nothing remains but its own distended form. Simulations show such fossil groups could form if mergers happened early and efficiently, leaving behind a single giant and a scattering of X-ray gas too faint to detect. But even this doesn't fully explain the dark matter deficit. Could NGC 1132 have formed in a region of the universe where dark matter was inexplicably sparse? Or did some long-vanished process, a black hole's violent outburst, perhaps expel not just gas but the invisible halo itself? Then there's the haunting possibility that we're seeing a galaxy in retirement. After eons of mergers, its dark matter might have heated up, its particles scattered to wider orbits, leaving the halo diffuse and hard to detect. The stars, settled into their smooth elliptical shape, would bear no fingerprints of the chaos that birthed them. If true, NGC 1132 isn't just a fossil, it's a relic of a bygone era when the universe was smaller, collisions fiercer, and growth more reckless. Studying this solitary giant forces us to confront the gaps in our cosmic ledger. Galaxies aren't just products of gravity and gas. Their stories are written in invisible ink, in dark matter we can't see and mergers we can't trace. NGC 1132 stands as a reminder that for all our telescopes and simulations, some chapters of the universe's history stay stubbornly blank, whispering from the dark, daring us to unravel their secrets. Out of all the bizarre wonders we've explored, 3 stand out as the universe's most stubborn riddles, objects so strange they refuse to fit into any cosmic box. First, there's Hoag's object, the galaxy that shouldn't exist. That perfect golden ring floating in nothingness, with no sign of the collision that usually creates such structures, defies every model of galactic evolution. Is it the product of an ancient, invisible merger so precise it left no scars? Or does it hint at some undiscovered internal mechanism where galaxies can sculpt themselves into symmetry without outside help? Decades after its discovery, this celestial donut still mocks our understanding, its core a silent enigma surrounded by a halo of young, blue stars that somehow thrive in isolation. Then there's NGC 6240, the cosmic battlefield where 2 supermassive black holes spiral toward a cataclysmic merger. Most galaxies host one central black hole. This one somehow ended up with 2, each weighing hundreds of millions of solar masses, locked in a dance so tight they could fit within our solar system. Their gravitational tug-of-war has turned the galaxy into a fireworks show of star formation, with clusters so dense they rival dwarf galaxies. Yet the real mystery isn't just their inevitable collision, it's why they haven't already merged. Are they trapped in a gravitational stalemate, or is the universe saving this spectacle for a future epoch, teasing us with a slow-motion preview of the most violent event in cosmology? And who could forget Centaurus A, the Frankenstein's monster of galaxies? Part chaotic elliptical, part slashed through spiral, it's a patchwork of contradictions. That iconic dust belt, a gash of darkness across its glowing bulk, isn't just decoration. It's the scar of a past cannibalism event where a smaller galaxy was devoured and its remains smeared across the sky. Meanwhile, the supermassive black hole at its core fires jets of plasma hundreds of thousands of light years into space, one of them aimed directly at Earth. But here's the kicker: despite all this violence, Centaurus is weirdly young for an elliptical galaxy, still churning out stars when most of its kind are red and dead. Is it a spiral caught mid-transformation, or proof that elliptical galaxies can steal second chances? What ties these oddballs together isn't just their strangeness, it's how they expose the gaps in our cosmic rulebook. Hoag's object asks if galaxies can rewrite their own blueprints. NGC 6240 forces us to rethink how black holes co-evolve, and Centaurus blurs the line between galactic life and death. They're not just outliers, they're cosmic counterarguments, reminding us that for every law we think we've nailed down, the universe has a wild card up its sleeve. And that's the real lesson here. The universe isn't just stranger than we imagine, it's stranger than we can imagine, with every enigma pushing us to ask better questions. So the next time you gaze at the night sky, remember, out there in the dark, the weirdest wonders are still waiting to be found. These celestial oddities aren't just cosmic eye candy, they're revolutionizing our understanding of the universe's grandest processes, forcing scientists to rewrite the rules of galactic evolution. Take Hoag's object's perfect ring, for instance. Its pristine symmetry defies the prevailing theory that such structures only form through violent collisions. This cosmic donut suggests galaxies might possess hidden self-organizing mechanisms, internal dynamics that can sculpt order from chaos without external triggers. Astronomers are now running sophisticated simulations to test whether gravitational instabilities or resonance patterns could spontaneously generate these rings, a possibility that would upend decades of merger-centric models. Equally transformative is what colliding galaxies like the Antennae and Mice reveal about dark matter's role in cosmic architecture. When telescopes map their gravitational fields, they find invisible halos extending far beyond the visible wreckage. These halos act like cosmic glue, stabilizing tidal tails and shaping the merger's outcome. But here's the puzzle. In some systems, dark matter appears sticky, clinging to certain regions, while in others it's eerily absent, like in NGC 1132's anemic halo. These discrepancies hint that dark matter might interact with itself or ordinary matter in ways we've yet to fathom, perhaps through unknown forces or variable distribution patterns from the early universe. Then there's the black hole paradox. Conventional wisdom says galaxies and their central black holes grow in lockstep, but outliers like NGC 1277, where a monstrous black hole outweighs its host galaxy's stars by 14%, beg to differ. This fossil galaxy suggests some black holes formed first, acting as gravitational seeds around which galaxies assembled. Recent surveys of quasars in the early universe support this. They've found fully grown black holes existing mere hundreds of millions of years after the Big Bang, far too quickly for standard growth models. The leading theory, direct collapse, where primordial gas clouds skip the star-forming stage altogether, collapsing straight into black holes under extreme conditions we've yet to replicate in simulations. But perhaps the most humbling lesson comes from starburst rings like NGC 4314's. These tightly wound firestorms prove galactic evolution isn't just about gravity, it's a delicate dance of feedback loops. As young stars die in supernova, their explosions heat surrounding gas, preventing further star formation nearby while triggering it elsewhere. This self-regulating mechanism explains why galaxies don't burn through their fuel all at once, maintaining equilibrium over billions of years. Yet when this balance is disrupted, like in the silver coin galaxies, superwind, the results are catastrophic, with entire galaxies starving themselves in fits of reckless stellar birth. The unanswered questions loom large. Why do some mergers produce polar rings like NGC 4650, while others create amorphous blobs? How do galaxies like NGC 7742 maintain such precise resonance rings without continuous external feeding? And what unseen physics allows NGC 2685's multiple misaligned disks to coexist without tearing each other apart? Each mystery is a thread in the universe's grand tapestry, pulling us toward deeper revelations about dark matter's nature, the birth of supermassive black holes, and the fundamental laws governing cosmic structure. One thing's certain, these peculiar galaxies aren't exceptions to the rules, they're signposts pointing toward richer, more complex rules we've yet to discover. As telescopes like JWST peer further back in time and supercomputers refine their simulations, every strange spiral, warped ring, and cannibalized core brings us closer to answering astronomy's oldest question: how does chaos sculpt the cosmos into the beauty we see today? Until then, we're left with a universe that's gloriously, tantalizingly messy, and infinitely more fascinating because of it. For backyard astronomers, hunting down these cosmic oddities isn't just for professionals. Many are within reach of modest telescopes if you know where and when to look. Start with the Black Eye Galaxy in Coma Berenices, best seen in spring evenings. Its distinctive dark dust lane is visible through an 8-inch telescope as a smoky smudge across the bright core. Look for it near the star diadem, forming a triangle with Arcturus and Denebola. The Sombrero Galaxy, a summer jewel in Virgo, reveals its famous dust lane even in 6-inch scopes when viewed from dark sky sites. Find it by star-hopping from Spica toward the Corvus constellation, where it glows like a celestial wide-brimmed hat. Winter skies offer the Whirlpool Galaxy, its spiral arms tantalizingly detectable through 10-inch apertures under pristine conditions. Track it down by drawing a line from Alcade at the end of the Big Dipper's handle to Cor Caroli in Canes Venatici. The Whirlpool sits almost halfway between them. For something truly unique, chase Hoag's object in Serpens during late spring. Despite its unusual structure, a 12-inch telescope can reveal its eerie ring as a faint halo around a brighter core, though you'll need exceptionally steady air and no moonlight to spot this cosmic donut. Timing matters as much as equipment. Plan observations during new moon phases when galactic details pop against the blackest skies. Many of these objects need low magnification to preserve their faint extensions. Start with a wide-field eyepiece before zooming in. Apps like Stellarium can help pinpoint them, but nothing beats old-fashioned star hopping for the thrill of discovery. Patience is key. Let your eyes adapt for 30 minutes and use averted vision to tease out subtle structures. Some, like the mice galaxies, remain challenging even for seasoned observers. Their elongated tails require pristine conditions and at least 14 inches of aperture to resolve. What makes these objects so rewarding isn't just ticking them off a list, it's connecting visually with cosmic processes. When you spot the Cartwheel Galaxy's fractured ring through a large Dobsonian, you're witnessing the aftermath of a collision that occurred before mammals ruled Earth. Catching Centaurus A's jagged dust lane means seeing galactic cannibalism firsthand. Every photon reaching your retina has traveled millions of years just to whisper these stories. So grab your star charts, pack your red flashlight, and let these celestial oddities remind you. The universe's greatest wonders aren't just in textbooks, they're waiting in your backyard, ready to blow your mind one eyepiece view at a time. The mysteries hidden within the NGC catalogue won't stay secrets forever. Cutting-edge telescopes poised to launch in the coming years are armed with technology that could crack these cosmic enigmas wide open. Leading the charge is the James Webb Space Telescope, already revolutionizing our view of the universe with its infrared eyes. While Hubble showed us the haunting beauty of the black-eye galaxy's counter-rotating disks, JWST peers through its dust lanes to trace the molecular fingerprints of that ancient collision, revealing how much gas remains to fuel future star birth. But the real game-changer, its ability to dissect the chemistry of polar ring galaxies like NGC 2685. By analyzing the isotopic ratios in their misaligned disks, Webb could finally prove whether these structures were built from cannibalized dwarf galaxies or sculpted by dark matter's invisible hand. Then there's the Nancy Grace Roman Space Telescope, set to launch in the mid-2020s. Where JWST zooms in for exquisite detail, Roman sweeps wide, its field of view 100 times larger than Hubble's. This makes it the ultimate detective for galactic oddities, capable of spotting thousands of Hoag's object clones in a single observation. If perfect ring galaxies are rarer than 1 in 1,000, Roman's statistical power will either confirm their uniqueness or reveal an entire hidden population, forcing us to rethink how isolated rings self-assemble. Its coronagraph instrument will also hunt for faint tidal streams around galaxies like NGC 1132, exposing the ghostly remnants of past mergers that current telescopes miss. But the most tantalizing tool might be the Extremely Large Telescope, or ELT, now under construction in Chile's Atacama Desert. With a 39-meter primary mirror nearly 4 times wider than today's largest, it'll capture images 16 times sharper than Hubble. For colliding systems like the Antennae Galaxies, this means mapping individual star clusters within those chaotic tails, watching in real time as gravity reshapes them. The ALT's spectrographs could also clock the orbital speeds of NGC 6240's dueling black holes with pinpoint accuracy, testing whether they're truly spiraling inward or trapped in a gravitational standoff. These missions aren't working in isolation. Combine Webb's chemical analysis with Roman's census data and ELT's razor-sharp dynamics, and suddenly, galaxies that baffled us for decades start giving up their secrets. Take Centaurus A's jagged, dust-laden JWST mid-infrared instruments can spot complex organic molecules there. Roman will chart how its jets interact with surrounding dwarf galaxies, and ELT might catch plasma knots forming in those jets at sub-light-year resolution. It's a trifecta of perspectives that could finally explain how such a messy galaxy stays so oddly youthful. The biggest revelations might come from surprises these telescopes weren't even designed to find. When Hubble launched, no one expected it to discover dark energy or prove the universality of supermassive black holes. Similarly, as these new observatories turn their gaze toward NGC's strangest residents, they'll inevitably stumble upon phenomena we can't yet imagine. Perhaps a galaxy with 3 perfectly nested rings or a black hole merger caught mid-spin. Whatever they uncover, one thing's certain: the golden age of cosmic discovery isn't behind us, it's just beginning, and these peculiar galaxies hold the front row seats to the show. From the hypnotic symmetries of Hoag's object to the gravitational wrestling match inside NGC 6240, these 30 cosmic oddities prove one thing: the universe thrives on defying expectations. Every entry in the NGC catalog we've explored isn't just a curiosity. It's a challenge to our understanding of physics, a testament to the cosmos' boundless creativity. Consider the Whirlpool Galaxy's elegant spiral arms, spun into perfection by a companion's gravitational pull. Then contrast it with the Cartwheel Galaxy's shattered ring, a bullseye carved by catastrophe. Or marvel at how the Medusa Merger turns destruction into stellar rebirth, while the Silver Coin Galaxy's superwind blows away its own future. The diversity is staggering: polar rings that orbit at right angles, black holes hiccuping like cosmic metronomes, galaxies so isolated they resemble celestial ghost towns. What unites them isn't just their strangeness, but the questions they force us to ask. How does a galaxy like NGC 7742 craft a perfect starburst ring without a central black hole's involvement? Why does NGC 2685's chaos somehow hold itself together against all odds? Each mystery peels back another layer of the universe's rulebook, revealing chapters we didn't even know were missing. These aren't just static snapshots, they're dynamic laboratories where gravity, gas, and time conspire to create phenomena that stretch our imagination. Yet for all their differences, these objects share one profound truth. They remind us that the cosmos is anything but static. Galaxies collide, black holes feast, stars ignite and fade, all on scales so vast they dwarf human timelines. And somewhere in that dance of forces, we're left to wonder, if the universe can craft something as delicate as the Sunflower Galaxy's fragmented arms or as violent as Centaurus A's plasma jets, what else is waiting to be discovered? Now it's your turn. Which of these celestial rebels captured your imagination? Was it the haunting perfection of Hoag's ring or the explosive choreography of the Antennae Galaxies? Maybe the eerie counter-rotation of the Black Eye Galaxy left you spellbound, or NGC 1132's ghostly solitude sparked your curiosity. Drop your favorite in the comments. We'll keep the conversation stargazing. Because the NGC catalog isn't just a list, it's an invitation to look up and remember. The universe's weirdest wonders are still out there, whispering their secrets to anyone willing to listen.